Okay, question 4 on page 38. It says a black color coat in Cocker Spaniels is dominant to white. Okay, let's not read anymore. If we can do a legend right away, let's do it. Capital B, doesn't matter what the other allele is, that's going to be black. And if I have two little b's, that's going to make it a white Cocker Spaniel. Okay, solid color, capital S, is dominant to spotted. So if I have a capital S, doesn't matter what the other allele is, that's going to be solid. And if I have two little s's, make them very different than your big S's, that's going to be spotted. Okay, so there's our legend. Often the toughest thing to do. If you get the legend wrong, probably everything else is going to be wrong as well. And all they're saying here is the pattern arranged is located, or pattern arrangement is located on a different chromosome than the one for color. And they segregate independently of each other, so they don't interact when they break into gametes. Okay, so now it says a black male with solid patterns is mated with 3 females. So here is a best practice strategy. When you're having multiple, let's say a male or whatever, mating with multiple females, and you're going to see this coming up again later on when we look at polygenetic questions. The best way to do this type of questions when you have this is with a table. Okay, that's best practices. And you can see when they're giving us a bunch of offspring, they're telling us a bunch of offspring that these different mating patterns are going to provide us. When you see that type of questions and they're asking for the genotypes of the parents, we know that we can't do a Punnett, no Punnett square, because you must have the genotype of the parents to be able to isolate the gametes to be able to do a Punnett square. So kind of a different question. So we're going to do a table. We have a black male mating with a female a female B, and a female C. So this is the table. Again, best practices. It's always good to isolate these different mating patterns. Okay, so what do we know about the black male? The black male is black. So if he's black, he has to have a capital B. We don't know the other allele. Okay, he could be homo black or hetero black. We don't know. And he's solid pattern. So if he's solid, go back and look at our legend. He must have a capital S, but we don't know what his other allele is. Again, we don't know if he's homo, capital S, or if he's heterosolid, capital S, little s. So that's all we actually know about the black male dog here. Now he's hooking up with female A. Now, female A, what do we know about her? So we're going to put what we do know about her and align what we don't. She's white and she's solid. So if she's white, we go back and take a look at our legend. She must have little b's, has to. And if she's solid, she must have a capital S. And again, we don't know what the other allele is. Nowhere's in that question or in that mating does it say if she's hetero or homo. Okay, but let's take a look at what they had for offspring. Now this is very similar. We've seen these type of questions with monohybrids before. We're going to go look at babies, but we're not going to look at any old babies. We're going to look for recessive babies. Recessive babies tell us a lot. So that's what we're going to look for here. So of course, the recessive traits are white or spotted. So out of these 4 puppies, we're going to see if they had any white. Yes, they did. And did they have any spotted? No spotted, right? But because they had white, we know that this baby had part of his genotype as little b's. So we know that that female A, well, that's all she could have contributed. But we now know that this black male must have been heterozygous for that. He must have donated for there to be white offspring, puppies. Each parent must have contributed one of the recessive B alleles, white alleles, for there to be that offspring present. So that's how we know he's heterozygous. Now, because they're all solid, everything is solid. For now, what we're going to do is we're going to say, well, okay, that's probably a capital S and maybe a capital S. Now, we may get some other information later on that changes that, so it's always good to have a pencil when you're doing genetics, because sometimes you might have to, we get more information down the road and we have to go back and change some of the genotype. But for now, that's what we're going to put down there. Okay, so that's this one here. So now the black male mated with female B, and female B is black and solid. So let's put what we do know about her. If she's black, she must have a capital B. Nowhere does it say homo or hetero, so we're going to put a line in there. She's solid, so she has to have at least a capital S. Again, nowhere does it say homo or hetero solid, so we're going to put a line indicating that we don't know what the other allele. We know there's something there because, again, all these traits are always in paired alleles. But at this point, we don't know if they're homo or hetero. Now, again, when you don't know the genotypes, we don't do Punnett squares. I've had students do 3 or 4 Punnett squares to solve this problem, spend 15, 20 minutes and still get the answer wrong. This is the best practice. Use a table, put a line what you don't know about the parent, and then look for offspring. Now, in this case, they only had one puppy. But again, we're not looking for just any old puppy. We're looking for recessive puppies. And look at this. They had a white, which is a recessive trait, but also spotted, which is a recessive trait as well. So that means this puppy was little b, little s, little s. Well, that tells us now that both parents must have contributed one of these little b's. So we now know that female B must be carrying recessive white allele. And we already know that about the male already with the cross between female A. But we also can see that they had that one puppy they had was also spotted. So that means that female B must be carrying a little s. And now we have to go back here. We got more information. We're going to take that off and we're going to say, okay, we got more information hooked up with another female. And we now know that that's a little s. Because again, if there was a spotted offspring with that cross between the black male and the female B, both parents must be contributing a little s. So that's why we need our little eraser to be able to change that once we got new information. So far we're just gradually, again, filling this in. And you can see how a table makes this easier to identify what the genotype of the parents are based on the offspring that they produce. So let's look at female C. So this guy's getting a lot of action here. So black male is also mating with female C, and she is white and spotted. Well, if she's white, she must have 2 little recessive white alleles, in this case being little b's. And if she's spotted, she must have 2 little s's. So in this case, we don't even care what the puppies are. Just because she was white and spotted, 2 little s's, we already know her genotype. And again, the question was indicate the genotypes of the parents. We have all 3 based on the offspring that they produced, and not one Punnett square was necessary. So utilize best practices when you see these type of questions. And again, just to reiterate, when you have multiple mating patterns going on, so you have a male mating with multiple females, use a table. And then what you do is systematically isolate what you do know about those parents, and then a line indicating what you don't know, and then go look at babies. And when you look at the offspring, you're not looking at any old offspring, you're looking for recessive offspring, and you start filling in some of these unknown lines here. Okay, best practices, that's the best way to get through this question. Okay, any questions, just give me an email. Thanks, guys.